I think we are live, right?
We are live. We are live.
All right,
Just a
great.
second.
Yeah.
The link एक बार share कर दो.
I mean, if you want, also we can probably put up that time. Yeah, the timer or countdown.
Yeah, sure. So we are waiting for more 5 minutes to everyone to get joined. Then we will be
Yeah, yeah.
starting today. Just more five
All right.
minutes.
Yeah. Yeah. Not a problem. Understood.
So Shivay, I guess now we can start. So hi everyone. Thank you for joining today's session. So today we have Shivay Lamba with us. So today it is our first session of the series of Be a Technical Guy. So today is our first session on Be a Machine Learning Guy, how you can kickstart your career in machine learning with Shivay Lamba. So Shivay is with us. He is right now CTO at a silicon-based company, Darkhorse, as well as he had worked a strong work experience over GSoC, over GCI. He had worked over the TensorFlow team, product lead at Layers 5, also worked over CodeChef, a strong work experience in AI/ML. So thank you, Shiva, for coming and giving us so much of time. All over to you.
Yeah. First of all, thank you so much, Anusup. And I think you've already given pretty much a compact introduction about myself. I have personally known Anusup for more than a year so far, and like what he has been doing, and specifically like what Man Ki Baat, is trying to do in the space of healthcare with the help of AI. That is something that is truly inspirational, and that is something that I'm personally vouching for, that it becomes a success in the near future. Like why we have gathered today is to understand what exactly is machine learning and how can one kickstart their career in machine learning. So what are the prerequisites that are required? What are some of the tips that I would want to personally give to everyone? Those are the things. But sort of to start off the session today, I'll be giving a very quick introduction to AI and what exactly is artificial intelligence and machine learning. So let me, without wasting any further time, let me quickly share my screen. Just give me 1 second. So can you add my screen to the live window, Anusup? Is it possible if you could add my screen I'm sharing? Yeah, great. All right. Thank you so much. So yeah, see, basically, without wasting any time, and for those people who might be new to what exactly is machine learning, right? What exactly is AI? So today, like we are going to be just talking over, an introduction about AI, what exactly is machine learning, about its workflows, and how to get started, right? So the first thing is what exactly is AI, right? We know that computers help solve problems of humans, right? We as human beings can only ever so work in a limited space, or let's say if you're working on a very difficult mathematical problem, you might not be able to work on it for more than 20 hours in a day, right? Because it can be very exhaustive. So that is where we want to use, or we want to sort of leverage the power of the computers, because you can give them some task and they can perform that for probably like 20-40 hours or even longer than that, right? So there are a lot of different processes that the humans perform, but we want our computers to perform those for us. So it started off by computers taking up basic tasks like creating simple calculations or doing things like file management. But we wanted the computers to also have the ability to think like humans and perform actions on their own. So far the computers were heavily dependent on the human input. So whatever input that you gave to them, they worked accordingly. But we wanted the computers to also make decisions on their own. So AI, or artificial intelligence, basically means that ability to give the computers or the machine to perform any task that requires human level intelligence. And when we say that we require human level intelligence, that means to be able to perceive your environment that is around you, or perceive the situation that you are in, then make certain observations based on that, and then based on the observations make certain decisions. And those decisions should be rational decisions that make sense and are able to solve a particular problem. And that is the entire premise of AI. And we actually see AI in our day-to-day life. So whether it is the email categorization of spam important emails in your Gmail, or it is finding out recommendations on the watch history on YouTube or Netflix, or let's say you search for a term on Google or any other random website, and you see product recommendations or advertisements of those searches that you made on Facebook or any like third party random site that you can think of. All of those involve AI in some form or the other, right? And then if you want to talk about some other examples, things like map and navigation, right? You want to go from one place to another. It provides you, like Google Map provides you the shortest possible route in terms of distance and also in terms of traffic. Then computer games, if you increase the level of difficulty, it becomes harder to understand, because what happens is that the computer is able to understand what might be your next move based on your previous set of moves that you do, and the level becomes harder and harder. And finally, we have the digital assistants that we all use in our day-to-day life. Those include like Siri, Google Assistant, Alexa, and all of these are able to understand the human language and able to react to it and respond in a human understandable language. And generally the computers, they work in zeros or ones, that is high voltage, low voltage. That is how traditionally they work. We call that as the machine level language that they work in. So it sounds very fascinating to see that how the computer or how the AI system is able to understand what we are speaking in our native language, and then actually replicate that and understand the problem that we are asking it to solve. So those are some of the common examples of AI. And like what we have seen is that AI is actually becoming very, very strong as we talk about it, right? So starting from beating players who are the world's top players in complex games like Go or chess, right? To be able to actually generate their own data, right? So what like this is an example that you might have heard. So it is Facebook who had created these bots that had generated their own language, and they were communicating with each other. So these shows that like AI today is becoming extremely powerful, and we are able to do a lot of different things. So for example, these are some of the examples. The first one that you see is neural style transfer. So what exactly is neural style transfer is that we have this technique called style transfer, where you take the characteristics of one AI system and you're able to superimpose those characteristics on top of another. And then something that you must have heard about are deep fakes that are able to regenerate people, and you're able to speak through them. So a really good example of that is, I'll quickly just show it to you. So if I go to youtube.com and if I go to the introduction to deep learning course by introduction to deep learning by MIT, right? If I show you that, you can see over here by Barack Obama, right? So this is probably a very famous video. So as you can see that Barack Obama is giving an introduction to deep learning, who was the ex president of the United States, and this video has actually been generated by the researchers at MIT, and it's completely fake. It's all using machine learning. And if you actually go and visit this video, they have synthesized his actual speech and generated this 3D model of Barack Obama, and they have been able to actually do it without any issue, right? So this is the power of AI, right? That we are able to do all of these amazing things, and that is why it has become very powerful as a tool to be used. So these are just one of the examples, or what we say as tip of the iceberg of what is actually possible with AI. Now the other thing that I wanted to speak about was that apart from these, like something that are the major goals specifically in AI. So those include problem solving. So one of the examples of this is that a lot of the research that goes on, right, whether it's like physical research, mathematical research, those require very difficult to understand programming languages, and like let's say very difficult to solve problems. Those like are very high level, high order mathematical equations that can take months and even years for people to solve. But since we say that the computers can work in a sustained environment for very long hours, we are using AI to solve such kind of scientific problems. We are using AI for self-learning, so being able to look at situations, self-learn, and implement themselves. That is basically machine learning. Use natural language processing, that is NLP. That is what the AI assistants that we have, they are able to do, being able to understand the natural language of the humans and work and sort of accordingly work on that. So these are some of the different tools that are, or sort of the different criterias on the basis of which we are having our AI systems work, right? So these are some of the things that you can also look at when you're working. So sensory perception is basically robotics, right? So robots today like are able to become very intelligent, right? They're able to sort of look at, okay, they're able to adapt to the human touch. So if you shout at them, or if you pinch them, they're able to react to it. So robotics today is actually a very big part of AI, right? It has become a very large part of AI. So these are some of the major goals and major places where you would see the application of artificial intelligence, right? And these are just some of them. You'll find AI being used in education, in healthcare, in defense, in agriculture, everywhere. AI today is everywhere, right? Give me just 1 second. So I'm sorry for that. And again, like some of the major goals, apart from these, what you have seen probably in science fiction is, what we know call as the super intelligence. That you'll obviously see a lot of different movies, a lot of different sci-fi shows where we say that we basically want to sort of make or paint the AIs that they can actually take over the world. So like these are some of the conceptions that we have, but like AI specifically in research also is being used in computer science, mathematics, psychology, right? Linguistics, philosophy. So these, all of these major sciences that we have today in world, you will find the use of AI, right? And so specifically talking about like what exactly is machine learning, right? So it's a very simple analogy that I like to give to people. So in a traditional programming program that you create, you'll be having your data, right? So let's say I'm trying to create a calculator based application. So your data is two numbers, and the program is, let's say we are trying to create a addition based program. So the data is, let's say, 2 comma 5, and the program is a plus sign. So in a traditional program, what will happen is that you give it the input, you give it the program, and it will render the output for you. So it will do the compute, it will render you the output as 7, right? Now the other one that we have is basically the machine learning based approach. Over here, what we are doing is that we're trying to find out what exactly is the thing that is going on behind. So you'll not be told that, okay, you're having a mathematical equation of addition going on. You'll be given, okay, let's say you have been given 2 and 5 and you have been given the result, so let's say 7. Now it is up to the program to actually predict what is the program, right? What is the uh, inner processing going on. So it will, let's say, predict, okay, it's an addition sign. Now once you have predicted what is going on behind the scenes, you can use that to actually make further predictions. So basically what happens in machine learning is that we are essentially doing pattern recognition, and what we're doing is that we get a lot of data, and we are able to extract information and extract features from that data. And once we extract those features, we're able to actually use that information to predict further knowledge. So let's say I'm creating a very simple machine learning application that is able to detect between images of mammals, fish, and birds. So initially what happens is that I define certain rules. In that I define, okay, these are the images of fish, mammal, and birds. It is able to extract those features, and then I give it a new image, and based on by comparing, okay, what are the features, and whichever features that are the closest to the computer, right, to the image that we have, we are able to make certain predictions and make decisions, right? So that is the entire premise of machine learning. Now this is like the machine learning pipeline, and this is where if you want to get started with machine learning, this is probably something that is the most important for you, right? So the first 20-25 minutes we have spoken about how what exactly is AI, what exactly is machine learning, to sort of give you. Now, before we move on to the machine learning pipeline, the most important steps that you have to keep in mind is that for getting started with machine learning, or getting started, there are majorly three different things that you should be aware. Now, to truly excel at machine learning and AI, there are three major things that you need to keep in mind. You need to at least know one programming language. Now, that programming language could be Python. So I'm telling you the preferred languages. These can be Python, R, or let's say Matplot. So these are some some good languages that you can get started with. You can also like probably do machine learning in like JavaScript or Java as well, but the preferred language that you could possibly use is actually like Python. Python is a great language to get started with because Python is super easy to understand. It's very beginner friendly, right? So Python is a great recommendation that I'll be having for everyone. Now, apart from learning at least the basics of programming, the two other three key criterias that comes to programming are or to machine learning are getting started with the statistics. So machine learning itself is very important, right? Like machine learning is very heavily focused on mathematics, heavily focused on statistics, and for that I will just sort of lay down a very short roadmap. So as I've said that the first thing that you need to know is, like, let's say, a programming language. So I'm denoting that by PL, right? Now the next thing that you will need is mathematics, right? So I'm denoting it by maths, right? You need maths, and what specifically in maths, like the specific topics that you need things like statistics, right? So mathematics and statistics, it's like I'm just correlating it to both as the same. And specifically in stats, things like calculating variance, covariance, right? Mean, uh, let's say mean, medium, right? All of those different things, right? All of those different tools are very very important. Things like hypothesis, right? Hypothesis generation. Then you need probability. Probability is another one of those that you need. So I'll just put it as prob, right? Probability is another one of those things that is very key to machine learning. Then you need things like linear algebra, so I'll denote it by LA. So LA is for linear algebra, again a very important topic. So mathematics is sort of the core fundamentals of machine learning, because what happens in machine learning is that any kind of a machine learning based program that we create, machine learning basically is running on the computer. And as we said that like the computer is not able to understand your general languages that you speak, or even the programming language. So generally what happens is that whatever program that you write, whether it's in C++, Python, in Java, it basically gets converted into the assembly language, and assembly language gets converted into the machine language, that is basically in the form of 0 1 0 1, right? So even in machine learning, basically whatever data that you are having, that is converted into a format that is in a mathematical representation. So whether it's natural language processing, where you have your speech or you're having words, those are actually converted into huge numerical arrays, matrices, and then we basically use a lot of different mathematical transformations and algorithms on the basis of that, right? So that is the most important thing to keep in mind, that whatever machine learning based problem that you're trying to solve, we basically have a mathematical representation of that, and internally it is the mathematics, it is the statistics, and it is the programming logic that we're writing to sort of work on these mathematical models and mathematical calculations that really works, and sort of internally how that works. So I hope that this makes sense to everyone. And to get started with programming, like specifically in machine learning, uh, as I've said that these are the key pillars that you really need to look at. So if you're an absolute beginner, right, if you have started out as an absolute beginner, uh, you should start off by basically learning a programming language, right? Preferably, like, let's say Python, right? Or let's say R, right? These are good programming languages to get started with. Learn statistics, right? And you can also like take up courses on AI, right? Taking up a few courses on machine learning, right? These are great way to get started with the theoretical knowledge about machine learning, knowing what are the different type of machine learning based algorithms, how to derive them, how to create the mathematical models behind those. So every machine learning language has mathematics behind it. So to sort of give you some resources on, let's say, Python. So Python, you can get started with, let's say, on Free Code Camp. That is a good resource. We have Python on Data Camp. That's also a really good resource, right? Python on Data Camp, you can get started with that. You can look at Python at Code Academy. That is also a good place if you want to go ahead and use. So these are some great resources to get started with Python. Now, for learning statistics, I have a recommendation for a YouTube channel that is, I think it is called Three Blue One Brown, if I'm not mistaken. Yeah, this will actually show you a lot of different tutorials, on, let's say, if you want to learn about linear algebra, right? You can learn about the basics of linear algebra at Three Blue One Brown. Like, again, like, it has a lot of different mathematical videos that it has like this playlist of 15 videos. But if you want to go deeper, you can look at a lot of different like statistical courses, stats courses on Coursera, right? I will give you just one of the examples, right? The top statistical courses that you can basically learn. The IBM data science one is good, or basically statistics, like University of Michigan courses is actually really good. So this will actually get you started, like essential statistical courses. And if you're wanting to get started with machine learning, probably the most important one that is by Andrew Envy, right? If you want to get started with machine learning, Andrew Envy course on machine learning on Coursera, right? So that is probably one of the biggest ones that is the world's most famous. And if you really want to understand what exactly is the most core at its core, most fundamental, right? If you want to understand that, that is where you can start learning these type of courses. Then you also have courses that are there by deeplearning.ai, right? So if you look at the courses offered by deeplearning.ai, basically deep learning, like I'll be talking about deep learning in a while, but this is also a great course. And if you want to like sort of go ahead and like dive really deep, we have courses on machine learning at I think it's called Udacity, right? So Udacity deep learning, or sorry, machine learning engineer. I think it's called Udacity Machine Learning Bootcamp or Nano Degree. This is also a great tool. You can also look at a few courses on Udemy, but basically the Udacity machine learning course is also a great one to get started or kickstart your career in machine learning. So the sort of the roadmap that we have, like I have defined to you, is that get started with Python as a programming language. Get started by learning, the core concepts of mathematics, Python, like specifically, probability, stats, right? All of those different things. Get started with these courses to understand how does machine learning work, how does basically machine learning, and what are the different type of algorithms, right? All of those will help you kickstart, make projects based on these on these things that you're learning, these algorithms that you're learning, and that will actually help you in the implementation as well. And again, like machine learning, you can actually go in two different ways, right? You can either go into research, because research is very heavily oriented towards machine learning, or you can go into the application side, right? Creating machine learning models to solve problems, or for applications. So you can go ahead in all of those different techniques. You can either go for research or for application development, right? But anyways, like machine learning is very, very easy to use, very sort of versatile. And again, there are a lot of different ways you can use machine learning for your day-to-day applications, right? So that is what is the major purpose of machine learning, right? Am I not audible, Anustu? By the way, are there any comments so far? I would love to, take up any questions till then. So Christian is asking, is there any necessary is it necessary to learn a language to perform image processing? So yes, Christian, like basically having to learn you could possibly do it like with just mathematical equations, but to actually see it live, to actually see it, you could possibly use a programming language, something like Matplot, or let's say R or Python, to actually see the results. You could possibly do it in like using this mathematical logical, but if you actually want to see it actually getting implemented, that is where you can use a programming language to your advantage. So let's say if you are having like a third party application or an application that you're creating, there you can basically use this like a programming language to actually see the results, or share the results with others, as well. So programming language becomes necessary over there. But if you really just want to see, okay, internally how does image processing work, that is where you will basically understand that you're using a lot of different mathematical operations, right? So I think, like, to make you understand basically how image processing works on a very 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 high level overview, right? Basically, your images are essentially these collection of pixels. So you basically can divide your entire image into different pixels, and each pixel represents one unique point. And we basically convert this entire into like a two-dimensional or a multi-dimensional matrix, where we sort of represent each pixel by a unique mathematical value, and we carry out operations on these matrices, on these arrays, and whatever changes that we make sort of make changes in the pixels. So all of these are mathematical tools, mathematical equations that we're doing, but to actually see it live, we use programming languages. I hope that answers your question, Christian. But yeah, anyways, like, these are like the steps that you should take up, right? Basically getting started with Python, right? Getting started with some mathematical tools that you can learn, right? Going over a few of these courses that I've shared about, and then making projects on the go, right? Doing research, reading research papers, all those will actually get started, or help you get a huge head start in machine learning, right? So now coming back to the machine learning pipeline, this is something that I wanted to really do a lot of emphasis on, because this is where is sort of lies our core concept of machine learning. So how is, like, how are we defining what exactly is a machine learning program, and what are the end-to-end steps that involve generation of a machine learning model, and actually making some kind of a prediction. So the first thing that we do is we define the problem, that hey, what is the problem that we are trying to solve, what is it that we are trying to do with machine learning, right? So the first step is to define the problem, that what exactly are we wanting to do, right? Yeah. Now the next thing that we do is that we collect the data, right? So basically, because as I said that the data oriented machine learning is very data oriented, right? So what that means is that like, what are we trying to do with data is that we are trying to find out what is the right or the requisite type of data that we need. So a data could be, let's say, data for like, let's say we are trying to detect whether a person has COVID by analyzing their x-rays. So the data over here is like x-rays of people, right? So then what we do is that we clean the data. So a lot of time what will happen is that the data that you will be having, it will be having duplicate values, it might be having missing values. and that can actually mess up with the data that you have, right? So if you have data that is not good enough, it will basically result in getting error values or taking more time to solve a problem. So we clean the data, we remove duplicate values, we remove missing values, right? Then we do something that is called as goal defining, like what is the main goal of our solution, what are we trying to solve. Then we do something called as feature engineering. We try to find out those kind of features that are most important. So let's say if I've been given like a data, right, to just sort of give a very quick example for that. If I have been given a data, right, so let's say the data that I have is like say a table, right? I have a table that has like the species of animal, right? And let's say what is its population, and let's say what is its nickname, like a common nickname for that animal, right? So if I am were to create like a machine learning model that basically wants to predict what is the species that is critically endangered, what are the features that I would want to take. So like of course having what is the species, what is its population. For me, like having like the name of that species, like the nickname of that species might not be useful. So basically feature engineering sort of states that you sort of take up those particular features in your data that are going to be the guiding factors in your machine learning algorithm, right, when you are training your machine learning algorithm. Because if you have more number of features or irrelevant features, those are not going to be useful for you, right? So basically to sort of understand, okay, what features are the most important for you, you basically do a lot of feature engineering where you find, okay, this is the feature that is the most important for me, right? So once you understand, identify those features, we start with the machine learning model training process, right? So the training process is where you basically are feeding in your data, you have written scripts of your model, and your model is sort of analyzing the training data. And once the training has been completed, we basically validate our model that, okay, the training has been completed, we give it new set of data, and we see what is the output that is being generated. If the output is good enough, we basically then you can move to further steps. But if you feel that like we are not getting the desired output, we basically send it back to the training phase where we train it again, and we see if the results this time are good. So it's sort of an iterative process, it's a repetitive process that we do to make sure that the predictions that we make and whatever things we're doing, those are like doing it well. So after we have sort of deployed our model, we basically use it to solve a particular problem, right? So that is the end-to-end machine learning pipeline. Now there are like basically three major different types of machine learning. We basically have supervised machine learning, we have unsupervised machine learning, and we have something called as reinforcement learning. Now specifically in supervised learning, we basically sort of you could say guide the machine learning model that, hey, what is the data that we are giving to it. So we basically define the classes of the data. And what does that mean is that we say that if we are trying to create a machine learning model that sort of differentiates between cats and dogs, right, images of cats and dogs, we actually tell the machine learning algorithm beforehand that, hey, this is the image of a cat, this is the image of a dog. So we are defining, or we are helping the machine learning algorithm know what exactly is the data and what does it actually represent. And it is able to understand the features from it and able to make a decision based on that. Now, the next one is unsupervised learning. So in unsupervised learning, we are not telling the machine, what exactly is going on, right? Like what we just give it the data, but we do not tell, okay, what is this data really at, So let's say if again I'm again, wanting to create a machine learning algorithm that is able to differentiate between images of cats and dogs. I will not tell it, even during the training phase that, hey, this is an image of a cat or this is an image of a dog. So the machine learning algorithm, what it will do is that right from the start, it will try to understand the features, and based on the similarity of the features within the training data, it will try to create two distinct types of data. And over here we call those as clusters, right? And then we have something called the reinforcement learning, which is basically a type of unsupervised learning only, but it is mostly like used a lot in robotics, gaming, where basically the machine is able to understand, like, the behavior based on its environment that it is in. Right, it is able to understand from the environment by a learning process. And again, like some of the common tasks that we have in machine learning, those include classification, right, regression. So classification is basically a type of algorithm that basically, what we do is that we create different classes of our data, right? So these classes, they represent different properties, and when we are given a new data, we want to classify it according to one of these different pre-existing classes that we have. Then we have regression, which basically works on a continuous set of data, right? So let's say if you have been given the rainfall that has taken place over the last few days. So if you have a continuous stream of data, you're able to make predictions on that kind of data. Clustering, as I've already said, that it's part of unsupervised learning, right? And basically, not moving too further. And again, if you want to get started with like machine learning, you can look at some of these resources, right? Now, before ending, I would also want to specifically talk about a topic that I had left out earlier, and that is something called as deep learning. So, as I said that AI, we wanted to make the human intelligence come into the machines, and that is the artificial intelligence. And one of the key proponents to that is the human brain, because the human brain is probably the most intelligent thing that is there, probably, if you don't have aliens. So we wanted to actually sort of re-modify, or sort of replicate that same structure of how information flows from a neuron to our limbs and we perform an action, right? We wanted to actually replicate that in the machines as well, and that led to the generation of artificial neural networks. So if you know how like a neuron structure looks like, right? If I quickly show you like how does a neuron look like. So neuron, right? If you look at the brain neuron, basically accepts the signals and it sends it over to other parts of the body, right? So similarly, the deep learning, or if I sort of show you, basically these are, you can consider these to be the nodes and these to be the neurons. So basically, we wanted to build like a algorithm, or basically a concept in machine learning and in computer science, that is able to replicate the brain structure and how the neurons transfer information from one part of the body to another. Similarly, in machine learning and in computer science as well, and that led to the development of something called as deep learning or neural networks. So these are a subcategory of machine learning, right? It can be considered like as a subset of machine learning, which basically uses these deep learning or these neural networks to, first of all, get the data, right? It basically trains itself on top of that data. It basically generates these things called weights, right? These weights are basically responsible for making sure, okay, what kind of prediction might come through. And deep learning is really great for a lot of different activities, or applications, like a lot of things related to image processing, video processing, computer vision, right? So you'll find a lot of its use cases in these fields, and again, it's highly optimized for such kind of applications for you. So just wanted to give a very quick introduction about machine learning. But also, one interesting fact that is there is that actually, like, AI based research, AI is not something that is very new, but basically things to actually study, okay, how we can understand the human brain, like how that works and how we can replicate that research. All of that actually has been there for almost 50 years now. So like research on AI and machine learning, deep learning, all of that is actually quite old. So that is just one point that I wanted to raise. But yeah, essentially that is what sort of gives us. So what we have learned so far is that we learned, okay, what exactly is AI, what exactly is machine learning, how to get started with machine learning, right? So for that, as I've told you, that the three main key proponents are getting started with Python or any other programming language like R, right? Learning the core fundamentals of statistics, linear algebra, probability, mathematics. Those will be very helpful. Then taking up probably a course on machine learning, right? And again, once you have gone through this course, there are various fields within machine learning, or within AI that themselves are individual research and PhDs based on just natural language processing, or PhDs is based on deep learning. So all of that makes basically like machine learning as a very very wide or like a vast topic. So there are endless number of possibilities that you can use with machine learning, right? So that is what is machine learning all about, right? So if anyone has any questions, then with that I would want to probably stop. But if anyone has any questions regarding how to kickstart your career, and again to also sort of give you a view that as a machine learning engineer you can work in research, you can work as like a machine learning developer, or you can work as a software developer who generates machine learning models. Then we have something called as the ML ops, that is machine learning operations, which basically is generating a machine learning model, but then also deploying it to cloud and making it interact with your website or any other like software that you might be having. So there are different paths that you can actually take up. So after you know the basics of machine learning, right, I'll also just sort of give you like sort of a career graph that you can take up. So let me quickly share that. So by learning machine learning, right, if you know the concepts of machine learning, right, you can actually go to like research. You could become like a PhD student, right? You could become professor, right? You could go to research, right? And again, sorry for my handwriting. Then the third one is like you can become an ML engineer, right? You could become an ML engineer. Then you can probably also do something like as a research engineer, right? You can look at ML ops. You can look at standard software development, right? ML ops, standard software development. So all of these different research like different ways you can look at. So if anyone has any other questions, feel free to ask.
Yeah, if anyone is having any question, please ask on the chat section.
And so if you want to probably share something, what you feel from a perspective of starting the career, I mean, feel free to also pitch in.
Yeah, sure. So thank you again for this was a really very insightful session. Very
Yeah, thank
insightful session to kickstart your career on machine learning. So again, if anyone of you is having any type of query, how to kickstart your career, what kind of things you can do, how to make up your project, anything you can ask on the chat section. Okay, so thank you, Shivay. I guess there is no other query from the audience section.
yeah.
So now I guess we can drop the session. Thank you so much for your time. Also, it was a very insightful session. Thank you so much.
Thank you.
So there is no other query from the audience section. Thank you again, everyone, for joining,
No,
and
thank you very
Shivay
much.
also.
No.